Okay, this is LeetCode 21 merge to sorted list. So you're given two heads of sorted linked lists, list 1 and list 2. So this is the head of the first list and this is the head of the second list. And you're told to merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first and two lists. So what they mean by this is that they don't want us to create copies of the nodes, I believe. They want us to basically shift these nodes inwards on each other so that we're just splicing them together, basically. Because we could easily just go through this and count the values, right, and maybe add them to like an array or something like that, or just create like a new value, create a whole new list and just go by one, which one's greater, and then add them to the linked list. But they don't want us to do that because that would take O of n space. And then they want us to return the head of the new merged linked list. Great. So we're given two linked lists. They're both in ascending order. So for example, if we were given this list and this list, the output would be 1, 1, 2, which comes from this value, 3, which comes from this value, then this 4, then this 4. So you can see it's the entire, both lists were spliced together so that we get one giant list, but it's still in ascending order. This one, both lists are empty, so we just return nothing. And then this one, we only have one value in a list, so we return just that one value. Okay, and then the number of nodes can be from 0, so yeah, we could have an empty list, or we can have all the way up to 50, and then node values can be from -100 to 100. Okay, so how are we going to solve this? So if you're familiar with other problems such as reverse a linked list, this will help you out because it's kind of uses the same concept. So we're going to use two pointers. So what we're going to do is to make this easier, we're going to have oops, let me plug in my laptop really quick. Okay, so we're back. So as I was saying, so we're given the heads of the list, right? So this list 1 is here, list 1, and then list 2 is the value associated with this node, right? Okay. And then what we want to do is splice these lists together. So to make this easier, what we're going to do is we're going to create a dummy node. So let's say we created a dummy node like this, and it's going to have, we should put like -1 in it, and this is the dummy node. Let me type this out because this is a little hard to type out. Dummy node, okay? So we created a dummy node, and then what we're going to do is we're going to look at each list and say which value is less than the other. There are going to be scenarios where maybe our values are equal to each other, so then in that case we can just choose either of the both and then just append that node here. So what we're going to do is we're going to say dummy node dot next, or we're going to create a connection here. It's going to be, let's just say we'll use list 2. So now we have this, and then that value is gone. But now this list 2 is going to be pointed to this. So before we perform this operation, we actually need to get a temp variable, temporary. So let's call this temp2, and let's just do this for this as well. Temp1, or this could even be next value or next node, but I'm just going to keep them as temp because that's how I like to think about it. Okay, And then next, how we're gonna move this over is we're gonna say list2 is equal to temp. So then this is gonna shift over to here. This list value is gonna shift over here. So now we're at this node, and we're just gonna continuously do this process, right? And then eventually we're gonna build our linked list like this. And eventually one of the nodes or one of the lists is gonna run out, I believe. So let's go ahead and just keep doing this. So now we're gonna have list 1. I'm not gonna remove all the pointers, but you kind of get the gist of the algorithm, right? So now we're gonna move this one, which comes from here where the stars come in, right? And then this is gonna move over. And then we also got to move our temp value. Okay. Now what's greater or what's less? What's the least value, I guess, like the minimum value of these two numbers? It's 2. So we're gonna move this node here, right? We're not creating a whole new node, we're just moving this node here. Okay. And then now this node's gone, right? And then now we can just say list 1 is here. Okay. And then we'll have 4 to 3, we get 3 is the minimum. Now both list 2 and list 1 are at the final nodes, right? And then temp would be at none or null, because as you can see in the list class here, the default value, if there is no next value, it's going to be none. This basically means that it's the default value. So we're going to have none be equal to our temp, right? For both of our temps, temp 1 and temp 2. Okay. And then what we're going to do is either of the two we can add. So we're just going to add the 4 from the bottom, right? And then at this point, we're going to increment our list 2. We're going to keep incrementing them. And then list 2 is going to be equal to none. So at that point, we're going to stop our loop. And then once we exit the loop, we're just going to check, does list 1 or list 2 have any extra values? If it does, then just append it to this list. So then we can just add list 1, the remainder of it being this node, to the end of the list. And then we get our whole linked list, which is sorted. And then what do we return? We might be inclined to just return dummy node, but that would include this new value that we've added. So we're going to do dummy node.next. Okay, so that's the algorithm. So let's go ahead and type this out. I'm going to leave the text up just to see if it'll as reference, and then I'll get rid of it if it gets in the way. Okay, so let's see. Okay, so we're going to create a dummy node, right? Dummy node is equal to list node. And we're going to create, the value is just going to be -1, and then the next value, you don't have to write this. If you don't provide anything for next, it's going to automatically be none, but I'm just going to explicitly provide it. Okay. And then this is a good kind of tactic for a lot of these linked list questions. It makes the problem a lot easier to deal with. Okay, and then we're gonna say we're gonna have to do a loop, right? So while, what's gonna be our condition? Our condition is while list 1 and list 2 are not equal to none. So while list 1 does not equal none and list 2 does not equal none, then we're going to keep going. This could also be abbreviated to just say while list 1 and list 2. It's basically the same syntax in Python, but I'm just going to explicitly say it like this, so it's a little easier to read. So yeah, while both of our nodes are not equal to none, we're going to compare the values. If list1 dot value, list1 dot val is less than, because we want to grab the less than value, right? Because we want the outputted list to be still in ascending order. So is less than list2 dot val, then that means that we're going to add list1 to the dummy node dot next. But before we do that, we need to store a temp variable. So we're going to temp1. Actually, we can probably just store temp1 above. Temp1 is equal to list1 dot next, and then temp2 is equal to list2 dot next. Great. Okay, so then what we can do is list1 dot val. So we're going to say dummy node. Actually, and then because we want to retain this value, so this is what we're going to return at the end. I'm just going to do this right here before we forget. Return dummy node dot next. So we want to retain this value, so we're not going to mess with this at all. I'm going to just have another value called current node is equal to, and we're going to set it to the same dummy node. Okay. And now what we're going to do is just say dummy node or current node dot next is equal to list1. Okay. And now what do we need to do after we've done that? Well, we can just update list1 is equal to temp1. Okay, and then let me move this out of the way. Let me erase this. Okay. Otherwise, you can do elif. You can do another if statement to say if list2 value is less than list1 value, you can do that. But in the scenario where they're equal to, we're just gonna use the list2 value. So we can just say else. So basically what I'm saying is that this else is gonna catch the scenarios where list2 dot val is less than list1 dot val, or list2 dot val is equal to list1 dot val. This is the scenarios where this else is gonna catch, basically, when it's gonna be ran. So then we're just gonna do what we did on line 14 and 15. We're just gonna copy these, current node dot next, but instead of list2 or instead of list1, we're gonna use list2, and then we're gonna increment our list2 to be temp2. Let me get rid of this little red mark. Okay. Yeah, and then I believe we can just move our current node. We have to move our current node as well. So current node is equal to current node dot next, and that's just going to move it so that our current node, it's basically, this current node is the node we're going to be appending to always to create our new list. Okay, and then I think that should be good for inside of the while loop. And then, like I said earlier, there's at a point here, one of our lists is going to terminate before the other. So what we can do is just say if list1 does not equal none, or you could just say if list1, like that, same syntax, but I'm just going to delete that. If list 1 does not equal none, then we're just going to say current node dot next is equal to list 1, and then otherwise, or we're going to also have one more if list 2 does not equal none, then we're going to say current node dot next is equal to list 2. So basically what this is saying is if there's any remainder of the list that terminated early, we want to make sure that we've grabbed that extra element that we didn't get in this while loop, because one of the lists is gonna be equal to none before the other. So we want to make sure we get that last value. Okay, and I think that should be it. Let's go ahead and try to run this, see if I made any errors. Great, so yeah, that's merged two lists. So let me go ahead and just go over the time and space complexities. So time would be O of n, I believe. O of n, where n is the length of, actually, to be a little more specific, I think we could say it's O of n plus m, right? And then this is an addition sign right here, a plus sign. N happens to be the length of list 1, right here where I'm underlining list 1. It's going to be the length or the number of nodes in list 1. And then m, right here, is going to be the length of list 2. So this is our time, because in the worst case scenario, which is pretty much every scenario, we're going to have to iterate through every node of both list 1 and list 2. So we're going to add them both, the lengths of both, which is going to give us our time complexity. Okay, and then space is a little tricky. I'm not too sure about this. I don't think that we're using any extra space, because I think we're just moving the nodes' values. This dummy node is constant time. This current node is constant time. These temps should be also constant time. Yeah, I want to say that our algorithm is O of 1 time, because even though we are appending nodes to a new kind of head node, the dummy node, we're just using these same values. We're not creating new values, I believe. So I want to say that it's O of 1. I might be wrong with that. It might be O of n. But my initial thought would be O of 1 for time. Yeah, so this is merged two sorted lists. Thanks for watching.